working on the plan to perform pre-construction process webinar, and we'll start immediately. I'm assuming that for those of us on the seminar, we're having various aspects of the construction industry. So as we continue the conversation, please, anytime I touch on a topic that you have questions on, just put it in the chat section. And also a heads up, some of the videos that I'll be playing, some of them might have some components that are repeated because of the workflows. It's to ensure that you gain deeper insight from the repetitions. So just keep that in mind. So why pre-construction? We have 220 million construction personnel working on different construction sites all over the world. And the current way of working has led to an estimated 40% wastage of materials on site. Meanwhile, owners typically expect that they're going to pay extra costs from omissions from the consultants and professionals that they engage on their projects. While the typical project has a 20% schedule overrun and an increase of 3 to 5% on projected cost of project. This is the way we currently work. In silos, different versions, different formats. Communication is scattered all over the place, and it's difficult to keep track of what is current. This means in the office, you get a computer that can handle whatever version of the software you want to work on. You buy the software, and you use the software to generate a file, which you now send via email, Dropbox, Google Drive to the consultants and stakeholders that need to use them. But this is the new way of working that Autodesk is developing and has been working on for a while and has invested in. Project-centric, where the project itself is the focal point of all communication, all design logic, and you have it as a single source of truth, and you have access to version control, no more looking for the latest version of any file, and you also have visibility of the supply chain. Using this format, it's easy for you to easily configure the software applications that you will be using. You can generate scripts that would give you the exact result that you want, and you can also work from 2D through to 5D, that is scheduling and costs. So in all, we have an integrated construction platform that manages the project from design to occupancy, and also includes fabrication in the construction aspect and improves the communication between the office and the field. So before we go into the details of the pre-construction workflows, we'll look at the phases of construction so we can have an idea of who is working in what area. We have the pre-construction, which we'll be talking about. We also have construction execution, which is the actual process itself, and then commissioning and handover. For pre-construction, we have the architects, main contractors, engineers, and in this phase, what is happening is everyone involved is trying to agree on what is to be built and how it is to be built. That is the thing we'll be focusing on today. We'll leave the other areas and just move on to the flow of information. So what happens is information starts from the initiation of the project until the commissioning and handover. And in the pre-construction stage that we're interested in, it starts with the design model itself, generates specification data, and you have the coordinated model, which spills over into the construction execution stage. So the output generally consists of your documented design documentation and running clashes to ensure that clashes are detected. We'll move on to the first aspect of the construction modeling phase for pre-construction. Now, construction modeling has the following typical business challenge. The design to construction process is fragmented. It is not holistic, it's not in one place. And you find out that all the information required to construct the building is typically not captured in the model itself. You require extra details for construction, and even the schedules and quantities are usually not construction accurate, meaning that they are not accurate enough for construction information. You have annotations that are required or they are still missing. So how would an ideal construction modeling workflow look like? You'll be able to have insight that would enhance the constructability of the project at an earlier stage in the process. You have access to multidisciplinary building content to enable you better manage the project. And you'll be able to extend your BIM data for use in crash detection, construction analysis, and fabrication. There are a lot more of these characteristics, but what we now have is the Autodesk workflow for construction modeling, which we refer to as the collaborative construction modeling. It has a suite of different softwares where information flows from one to the other to achieve the following: create a constructability model, then to update the central model you're working on. You know, we said you're working in a project-centric process. To have direct access to all team members for clarity, to be able to organize your documents effectively, and to extend the workflows in Navisworks. So we'll look at a short video that gives an overview of this. Please mind that some of the names of these softwares have been merged into BIM 360 platform.
When construction companies receive design models, they will likely need to create a constructability model to add more detail to the project. Using tools such as Autodesk Collaboration for Revit, BIM 360 Team, and BIM 360 Docs allows the entire team to work on the constructability model from any location. To get started, the VDC or BIM manager will create a project on BIM 360 Team. After the project is created, they can invite team members to the project and choose what role they will have on the project. Using Autodesk Collaboration for Revit, the VDC manager will then upload the project to BIM 360 Team. Once the file is uploaded, the other team members can access the project from within Revit and begin to create the constructability model. To collaborate in real time with other team members, use the Communicator tool. This will ensure that everyone is on the same page and will keep a record of the decisions that are made along the way. You can also view the project's Sync with Central activity from the Timeline tab in the Communicator. Once the constructability model has been created, the model and documentation can be uploaded to BIM 360 Docs, so the entire team has access to the information from any location. Also, BIM 360 Docs allows you to create a folder structure, so project information can be organized and easily found. Utilizing the cloud for collaboration ensures the entire team has the latest project data whenever they need it. It also provides easy access to the constructability model for extended workflows, such as creating quantity takeoffs, project schedules, and clash reports in Autodesk Navisworks or BIM 360 Glue.
Okay, so that's the first workflow we have in the construction modeling process. The next is construction detailing, which entails you creating detailed schedules, communicating these details using advanced drafting tools, and ability to have revisioning and markup included.
Many construction companies are using Revit to develop detailed 3D constructability models. However, most job sites are still using 2D drawings. This requires the VDC team to produce 2D representations of the constructability model using Autodesk Revit's advanced tools for drafting and scheduling. Because your 2D drawings are outputs from your 3D model, if something changes in one view, all the others are automatically updated. Revit also provides the ability to create 3D views with exploded details, which allows you to better convey the design and intended installation to workers on site. Many subcontractors use a 2D workflow to produce shop drawings or communicate with their team in the field. The general contractor or architect can provide subs with 2D background drawings created in Revit for use in AutoCAD. This allows them to continue their work in one of the most powerful detailing engines available to produce their 2D documentation. With cloud connectivity to AutoCAD 360 or BIM 360 Docs, you can easily share documentation for markup and review with the entire project team, regardless of their location. No drawing set is complete without descriptions of the materials and the assembly details, which is why adding annotations, line work, detail components, schedules, and quantities is a crucial phase of the complete BIM workflow.
Okay, so what we've been doing so far is focusing on the pre-construction stage, which is to ensure that we have sufficient information, enough to verify if the project can be constructed, and to handle the scheduling, the quantification, all the things that should go on before the project starts, that if handled very well, would minimize the risks that are typically associated with the construction project. So we'll go on to the quantification workflow, the process, and look at the typical business challenges faced by construction professionals. For quantification, the issues are that we need to have more accurate and reliable material quantities and cost estimates, and to be able to reduce the risks to profits on the project that come from exceeding budgets, and to reduce the manual processes that take so much time, are error prone, and can result in having inaccurate estimates. So how should the solution look like? You should be able to estimate earlier and constantly so that owners are able to make informed decisions, to be able to build on information as it becomes available, since on any typical project, all the information doesn't become available at any one point in time. It's spread out over time. To be able to use detailed spatial and material quantities to produce more accurate cost estimates and to perform takeoffs. So we'll go on to the workflow for quantification, which is split into the detailed scheduling from design using Revit, item and resource management, 3D model-based and 2D quantification, change analysis and reporting using Navisworks. So you can see that what we're doing is pairing the software, like I said before, as information flows through the entire construction timeline, it also flows through the software as well. So this short video gives us an overview.
Today's estimating processes rely heavily on 2D documentation and manual counting of project elements and components, which can be error-prone and very time-consuming. Leveraging a model-based workflow for quantification can reduce the time it takes to generate project quantities and enables workflows for adding valuable construction information to project elements during the process. Here we see how the Autodesk Construction Solutions offer several ways to gain access to the quantity information early in the planning process. By leveraging tools directly from the modeling applications, we can quickly get a high-level understanding of the project quantities. Schedules, or tables of data built from the model, created by the designer, can be used by adding counts and totals, or a custom table can be generated on the fly to give you the feedback and quantities from the model information immediately. Here we are working with item and resource catalog information in order to classify the model elements further than the model authoring tools can. With the catalogs available, we quantify the model using intuitive and easy-to-use tools in Navisworks. The quantification workbook is our central location to create and manage the quantities within our model. We simply select an appropriate item within the catalog for quantification and can either drag and drop elements from the model to the appropriate items Right-click on any model element and select the catalog item to use, or use a toolbar to quantify the elements on the fly. As we see here, once elements from the model are quantified, their display in the model is updated with the color and transparency settings from the catalog. This ensures that we see exactly what has been quantified and can quickly toggle between showing the model elements that are done versus the elements that haven't. The workbook also leverages the item breakdown structures and the resource breakdown structures, in that we can see a roll-up of the total quantities for an item collection with its resources, as well as the individual elements' detailed data. To complete the quantification of the model, we simply continue to walk through the workbook and pull model quantities into the system. 2D takeoff can now be done using the new intuitive and easy-to-use 2D takeoff tools directly in Navisworks. This can be done by opening the item catalog, drilling down to the appropriate categories, and adding the new items we plan to take off. Drawings can be cleaned by using the Hide Background and Annotations tool in the Navisworks Quantification Workbook. This allows you to hide all of the notes, room names, section markers, and more. We start by selecting the item type in the Quantification Workbook. Here we are taking off walls by selecting the wall line and then wall line type. We can also use other tools such as the Polyline tool or even the Rectangular Polyline tool. As we are taking off these items, they are being individually added to the Quantification Workbook, as well as being added together for a total. We can edit any line that we previously placed. We can add multiple elements at a time through the selection tree. Select the elements we want to take off to interior walls, and the Navisworks Quantification Workbook will be updated. Another challenge the quantification and estimating of building projects faces on a regular basis is the fact that project information inevitably changes. With a model-based approach and the use of the Autodesk Construction Solution, the management of changes is easy and effective. Because we are working with a model, the changes can be incorporated and tracked using Navisworks very easily. We see that the model within Navisworks has been refreshed, and we run an analysis for the quantities to see what has changed. An intuitive set of icons is showing us the changes and how they affect the quantification, along with tooltips that display the details of the changes. We can either accept the changes and they are incorporated into the new quantification, or we can remove the existing quantities and perform a fresh takeoff for the new or updated elements.
Okay, so that is for the quantification. Please, if you have questions as we go through each of the workflows and segments, just type it in now so that you do not forget. Okay, we'll go on to pre-construction coordination next. Now, what are the typical challenges of pre-construction coordination? Which is that projects are becoming more complex while delivery times are reducing. We have contributors at varying skill levels. Some are using 2D only, some are using Revit, some are fully BIM compliant, some are using even other softwares that give them different file formats from what the team is using. We have a lack of collaboration and access to BIM for distributed teams. Coordination review cycles are quite lengthy, and owners typically do not expect to pay for mistakes that come from the team. So, how should the solution look like? You should have access anywhere at any time to the latest project models and data. And the Autodesk solution helps to speed up project reviews and ensures that multidisciplinary teams can quickly identify and resolve pre-construction coordination issues. You can see this image here where the undetected clash has led to this creative solution. You should be able to have cloud-connected workflows for BIM coordination, collaboration, and analysis to ensure that all of these errors are detected early in the design process. So this is what happens when you carry out the pre-construction coordination properly. You detect such errors early enough and you can correct without having to get to site to create on-the-fly solutions. You also have support for 2D files and 50 plus different file formats using the Autodesk solution. So the problem of they are on another software or the file format is incompatible is resolved. So for the pre-construction coordination workflows, we have the following flow from the centralized multidisciplinary collaboration to real-time clash detection and resolution, round trip coordination, and field mobility. These are all different workflows that we'll walk through one after the other. We start with the centralized multidiscipline collaboration using BIM 360 Glue to manage all the different file formats, the versions, to create markups, and to send notifications and one-click access to BIM to all the professionals on the project. This next video gives us an overview.
Centralized multidiscipline collaboration is simple with Autodesk BIM 360 Glue. The first step in team collaboration is uploading discipline-specific project models to the BIM 360 Glue service. This can be accomplished using the BIM 360 desktop application. Simply select Upload Files, where you can drag and drop your project file or browse your computer. BIM 360 Glue supports over 50 file types, ensuring support for a wide range of design applications. A more efficient method to connect with Glue is to upload your models directly from the authoring application. This will allow you to regularly upload your model to BIM 360 Glue without leaving the application. In this example, we will upload a project model from Revit in just a few steps. First, create a 3D view in Revit that displays all the model information you'd like to include. It helps to rename the view to match the name you would like to have in BIM 360 Glue, but you can also rename the model before uploading to Glue. Go to the Add-ins tab and click the Glue icon. You should have already been invited to a project or set up your own project on BIM 360 through the Account Admin settings. Select a project from the list. Now select a view to upload as your model. Choose the 3D view you have created and click Glue it. A status bar showing that the model is uploading appears, and you will be informed that your model is being glued. Once the model has been successfully glued, you will be notified. This process should be repeated for all the project models. We now move to the BIM 360 desktop application, where we will merge the discipline-specific models that have been uploaded. Much like uploading the project models, merging can be accomplished in just a few steps. First, in the Merged Models section, select Add Merged Model. This will open a dialog box showing each of the projects that have been uploaded to BIM 360 Glue. Select the models you would like to merge, give the merged model a name, and select Merge Models. This will open a view of the merged model where you can check for clashes, create views and markups, and notify the team of this activity. As projects continue to move forward, having the most up-to-date project documents is critical. BIM 360 Glue allows you to view the version history of any of the uploaded models. To see the current version of a model, hover the cursor over a project. To view the version history, right-click on the model and select View Details, which opens a dialog box where you can see a list of versions in the lower right corner. You can also see version information on the model's list view and access the same View Details dialog box by right-clicking on the model. With the power of the cloud to manage versions, you are confident the team is always working on the most current version and secure knowing they can access older versions quickly and easily without digging through files to find them. Once the models are merged, you can begin to perform various collaboration tasks, such as checking for clashes or creating views with markups. In this example, we will create a view and create a markup that can be communicated to various team members. First, open the merged model. Notice the tools in the upper right-hand corner. The first thing we are going to do is turn off sections of the model using the Models tool. This allows you to limit the elements visible in the view you want to create. Next, we will create a view by selecting the Views tool. In the Views dialog box, notice you have the option to create views just for yourself or a shared view. In this case, we want to share this view with the team, so we will select the Shared Views section. Now, click on Add View, give the view a name, define who has access to the view, and click Save. Now, we're going to navigate away from the view to see how easy it is to get back to it once it has been defined. It's as easy as selecting it in the Views dialog. Now, we will create a markup in this view. Simply select the Markups tool and click Add. This will open a palette of markup tools at the top of the window. Let's change the color of the markup. Select the Freehand tool and draw in the view. Then select the Text tool to add a note and click Save. Notice the markup is specific to that view. When I navigate away from the view, the markup disappears. If I go back to the view, the markup will reappear. All activities are tracked in BIM 360 Glue, ensuring the team is aware of everything going on with the project. You can see the activities specific to the merged model by selecting the Activities tool. You can also see the activities for the entire project by selecting the project name or by going back to the main project page and viewing the Activities section on the right-hand side. Now that we've created a markup, we're going to communicate that markup to the owner. Because he isn't always monitoring the activity in BIM 360 Glue, and we want to make sure he's aware of this change. We are now back at the markup we created earlier. To communicate this view to the owner, select the Notify icon in the Markups dialog. Select the owner and add an optional message. Then click Send. The owner will then receive an email notifying him of the markup. You can even go into the activities, select multiple items, and notify a team member about them. As you have seen in this video, it's easy to upload models, merge them, create views and markups, and keep the team up to speed on all the project activity, whether they are in BIM 360 Glue or not.
So if you see the trend that the different workflows we've been showing you reveal, it's that the cloud is the point where you can carry out a lot of these activities. Don't forget, it is not limited to any location. You can gain access from mobile devices, from your iPad, from a laptop, whether you're on site or you are in the air, making sure that the anchoring to the computer in the office is removed. So we'll go on to the next workflow in the pre-construction coordination process, which is real-time clash detection and resolution. The two software titles we'll be using are Navisworks and BIM 360 Glue, which will help us manage clash sets, review organized clash results, clash comments and notifications, and give clash status management and resolution. This next video gives us an overview. Yes.
Clash detection done on the job site usually results in change orders, causing material waste, added cost, and added time to a construction project. Using Autodesk BIM 360 Glue's Clash Review allows the team to find and resolve potential issues right in the cloud before construction begins, resulting in less issues during construction. Let's start by checking for clashes using one of the merged models already in the project. In the Merged Model view, start by selecting the Clashes tool in the Tool palette. Click New in the Clashes dialog to create a new clash set. Select the portions of the model you want to compare, give the clash set a name, and click Find Clashes. You can see the results of the review in the Clashes dialog and in the model. In the Clash Results dialog, you can see the status and click to navigate to each of the clashes in order to view the objects that are clashing. As you can see, navigating from clash to clash is a quick and easy process. Now that you know where the clashes are located, you need to communicate these issues to the team. Using BIM 360 Glue makes this process easy by adding a markup or comment to each of the issues, or leave them as is. Then select a series of issues and notify the team members via email. In addition, anyone with access to the project in BIM 360 Glue can also view the clash set, comment on clashes, notify other team members, or change the status of a clash. Now that clashes have been found in the model, the individual model contributors can also review the issues directly in their design application using the Clash Pinpoint tool that is part of the BIM 360 add-in. To use the tool, open a view that contains the clashing elements. In this case, we're going to open a 3D view so we can see the entire building. On the BIM 360 add-in, select the Clash Pinpoint tool. Select the project and click Next. Select the clash result set you would like to use and click View. You now see the clashes we previously notified the team members about via email. Using the BIM 360 add-in tool allows each of the individual model contributors to easily find the clashing elements, fix the issue, and upload a new model to BIM 360 Glue once the issues have been resolved. Over time, the number of issues in the clash results set will go down as the team resolves them. This will produce a better coordinated project that will be built on time, on budget, and with less waste.
So that is the end of the second workflow in the pre-construction coordination. So next we have the round trip coordination, which involves the use of Revit and Navisworks used together.
Desktop to cloud model upload, merging, clash detection, and quantification are made easy with round-trip coordination. The first step is uploading discipline-specific project models to the BIM 360 Glue service. To do this, go to the Add-ins tab and click the Glue icon. Select a project from the list. Now select a view to upload as your model. Choose the 3D view you have created and click Glue it. A status bar showing that the model is uploading appears, and you will be informed that your model is being glued. Once the model has been successfully glued, you will be notified. This process should be repeated for all the project models. We now move to the BIM 360 desktop application, where we will merge the discipline-specific models that have been uploaded. Much like uploading the project models, merging can be accomplished in just a few steps. First, in the Merged Models section, select Add Merged Model. This will open a dialog box showing each of the projects that have been uploaded to BIM 360 Glue. Select the models you would like to merge, give the merged model a name, and select Merge Models. This will open a view of the merged model where you can check for clashes, create views and markups, and notify the team of this activity. Now, let's check for clashes using one of the merged models already in the project. In the Merged Model view, start by selecting the Clashes tool in the Tool palette. Click New in the Clashes dialog to create a new clash set. Select the portions of the model you want to compare, give the clash set a name, and click Find Clashes. You can see the results of the review in the Clashes dialog and in the model. In the Clash Results dialog, you can see the status and click to navigate to each of the clashes in order to view the objects that are clashing. As you can see, navigating from clash to clash is a quick and easy process. Now that you know where the clashes are located, you need to communicate these issues to the team. Using BIM 360 Glue makes this process easy by adding a markup or comment to each of the issues, or leave them as is. Then select a series of issues and notify the team members via email. In addition, anyone with access to the project in BIM 360 Glue can also view the clash set, comment on clashes, notify other team members, or change the status of a clash. As the project progresses, the models uploaded to BIM 360 Glue can be opened in Navisworks Manage and used for advanced workflows, such as scheduling and quantity takeoffs. In this case, we'll begin with the process of creating a quantity takeoff. We'll start by clicking on the project setup in the quantification workbook and select the catalog. Then select the project units, takeoff properties, and click Finish. This creates the data structure for your takeoff. It's then as simple as selecting elements in the model or selection tree and dragging them to the corresponding section of the quantification workbook. Once the quantification takeoff is set up, it can be updated as the model changes. You can also use 2D data sources to generate the takeoff for items with no associated model geometry or properties. Using these processes and keeping the project data up to date in the cloud provides the ability to do round-trip coordination.
Okay. So the last of the pre-construction coordination workflow is field mobility, which ensures that you are able to share information with stakeholders in the field. And you can gain one-click access to the project files. You can easily navigate even on your mobile devices, and you can add comment markups and specifications.
Often, there is a need to share the information in your models with stakeholders who either aren't directly involved in the coordination process, like field personnel, or just need progress checks, like an owner or project manager. This is where mobility can play a key role in extending the value of a coordinated model to these consumers. The notification system built into Glue allows you to select the team members you wish to collaborate with, type out a personal note, and send an email to them all in one simple step. Once this is done, you can go back to your task of visual coordination without ever stopping the process here in Glue. The result is time saved in sharing information with the key project stakeholders and ensuring the team members needed are communicated with securely and efficiently. When the email is received, all you need to do to view the model and markup that was shared is to select the hyperlink within the email that Glue sent. Glue will do all the heavy lifting, in that it will automatically launch, will load the exact model and version that contains the markup, and take the email recipient directly to the markup, streamlining the collaboration process with the mobile user. From here, we can interact with the model using straightforward navigation, using gestures for zoom, pan, and orbit. Tools for measurement, where we can verify model dimensions while we are in the field, and even showing the X, Y, and Z differences. Finally, the remote user can send a comment back to another team member directly from the mobile app. Using the BIM 360 Glue mobile app provides access to the project regardless of the user's location, and provides the remote user with tools to collaborate with other team members.
Okay, so we'll move on to the planning and logistics phase. What are the typical business challenges faced in this phase? We have the coordination and execution of complex building projects being difficult and time-consuming. We have a need to reduce costs and minimize safety and environmental performance risks, and to avoid the setbacks in scheduling that we have that result in significant delays in project delivery, drop-off costs, and create client dissatisfaction. The ideal situation would be that we are able to quickly visualize the proposed project within the context of existing conditions, that will be able to identify and resolve potential conflicts and address environmental and safety concerns before the construction even starts. That will be able to quickly access and quantify the impact that changes in the design and scope would have on all subcontractors and even on the overall project plan, and to explore options that you have based on trade-offs as you consider how to execute the work. So the workflow we have for this is a combination of these three software that will manage the scheduling and progress tracking in Navisworks, site planning in InfraWorks, and temporary works in Revit and Civil 3D. So we start with the scheduling and progress tracking workflow, as shown in this video.
Core to planning is understanding your schedule and project plan so you can assess the impact of changes and track progress. With cloud-based BIM coordination, project teams gain virtually anytime, anywhere access to connected project information. Autodesk BIM 360 Glue helps you perform multidisciplinary collaboration and coordination review cycles faster, while making construction layout tasks more efficient. In Autodesk Navisworks, we can open the models saved in BIM 360 Glue and perform extended workflows such as creating a project schedule. This is done by easily attaching model elements, even at a preliminary stage, to a schedule of tasks. Elements can be selected from a list, grouped together with selection sets, or simply highlighted on the screen and dragged and dropped to the appropriate tasks. Once we have a preliminary schedule and 4D simulation complete, we can easily export the data to an external third-party project scheduling application, such as Primavera or Microsoft Project, where it can be further refined, then linked back into Navisworks. BIM 360 field checklists provide the ability to collect data, such as daily updates, which allow contractors to better manage the process of daily job site performance reporting by providing a digital workflow that enables transparency of the collected information, which can be accessed by the project team at any time. By trapping the information within the BIM 360 ecosystem, you can better understand and manage risk, as well as gain insight into trends and analytics that expose root cause detail and allow you to track the planned work schedule to the actual progress in 4D simulations.
We'll move on to the next, which is site planning, which features InfraWorks, Civil 3D, and Navisworks.
Construction projects are more than just the building. There's the site as well. Using tools like Autodesk InfraWorks, Civil 3D, and Navisworks provides the team with insight into how to manage the site and the impact the project will have on the surrounding area. To begin, site planning tools like InfraWorks allow you to quickly create a model containing terrain, roads, buildings, water sources, and aerial imagery. This allows you to start making plans for the site at different phases of the project by easily creating zones for material layout, walking paths, and so on. Also, using library content for cranes, vehicles, and site trailers allows you to quickly populate the site with relevant equipment. Using these tools in InfraWorks allows you to quickly understand the context of the building and the effect the surrounding area may have on it. InfraWorks also has the ability to run traffic simulations, allowing you to look at alternate scenarios such as different entrance points to the site. Using the traffic simulator will provide the team with the understanding needed to lessen the impact on the surrounding area while maximizing the use of the construction site. As you continue to further refine the project site, you can leverage the Vehicle Tracker tool in Civil 3D to look at the movement of heavy equipment, such as cranes. This will ensure that you place materials, other equipment, and temporary site buildings in locations that allow for the equipment to move freely around the site. Finally, you can export the site information created in InfraWorks into Navisworks and join it with project information created in other applications, allowing the team to link it to construction simulations and help visualize and communicate the site to workers.
Final workflow of the planning and logistics phase is the creation of temporary works, which would involve these different software tools. I'll go straight to the video to outline this process.
Temporary works are increasingly being modeled to take advantage of downstream uses such as layout, construction simulation, clash detection, and quantification, as well as obvious reduction in risk for health and safety. For example, a temporary scaffolding layout can be designed using Revit using custom scaffolding families. The process to laying out the scaffolding is the same as laying out the building structure. Start by placing vertical elements of the scaffolding as columns and adjust their spacing as needed. Then place the horizontal elements as beams. Work in 2D and 3D views to ensure the scaffolding is being modeled correctly. Once the structure is complete, you can place the scaffold boards. After completing a section of scaffolding, you can use the Array tool to repeat it along the face of the building. Then, copy a group of scaffolding sections from level to level. Continue this process until you have completed the entire scaffolding structure. Once a section of scaffolding is complete, robot structural analysis can be used to look at wind loads and load-bearing capacity. Any necessary changes to the scaffolding model can be brought back into Revit. This process will ensure that the scaffolding will perform as desired, resulting in a safer job site. Revit isn't the only application that can be used to design specialty structures. Inventor can be used as well, leveraging the Revit model as a background. Using Inventor allows you to use manufacturing parts already created in Inventor, rather than recreating these elements in Revit, which will increase the time to model and add unnecessary detail. Doing this work in Inventor also results in the ability to quickly generate a parts list or send parts to manufacturing directly from the application. Both the Revit and Inventor models can be brought into Navisworks for review from multiple parties, as well as used for accurate layout using point layout or clash detection against the program to ensure they are installed or removed in time.
Okay, so we'll now look at the reconstruction business development. What are the typical business challenges? What are you trying to achieve? The fact is that the landscape is becoming extremely competitive. The construction industry is changing rapidly. We have 3D printing now, so many other new technologies coming up. Projects are becoming more complicated and more involving. Customers are expecting more, and you need to differentiate yourself from the competition. So the business development phase shows you how you can set yourself apart and indicate that you understand the challenges faced and that you have the answers and the solutions to this. So how would the ideal business development solution look like? You would be able to create realistic and interactive simulations and visualizations for the consumption of your clients. You are able to easily generate multiple alternatives and communicate project information to stakeholders as well. For the business development workflow, we have this connected workflow of Navisworks, online rendering, 3D Max, InfraWorks, and Recap Pro. That will take you through the process of showing that you understand how the project works, that you can present high-end visualizations, you can show the context of the project and how you intend to solve the problems you've identified, and to also visually verify site conditions. We'll look at this next video as it
Business development and winning work is rarely only about the price or schedule of the proposed work. Using the power of a digital workflow will allow you to demonstrate that you understand the work to be completed and the challenges you will need to overcome. Autodesk Navisworks is a key tool to show your understanding of the project, whether to show issues between interfaces of trades, simulating the construction and potential solutions, or just getting a quick bill of quantities to estimate from. With Navisworks' connection to the cloud, you're able to use the power of cloud rendering, which means that you no longer need to sit next to an idle computer for hours waiting for a single rendering. You can push your model to the cloud for rendering, and then you'll receive an email to download the render when it's complete. If you want really high-end renderings, you can use your digital data in Autodesk 3ds Max, Autodesk's Oscar-winning program for films, special effects, and scenes that look so real you may not know they're computer-generated. When it comes to overcoming objections from the public and other interested parties, tools like Autodesk InfraWorks allow you to quickly place your digital models in the context of their surroundings with the ability to create a map with roads, water, and buildings and terrain with high-quality aerial imagery for your presentations. Winning work can also mean understanding the existing and as-built conditions through a detailed scan. These scans in Autodesk Recap and Navisworks give you the ability to reaffirm buildable conditions and analyze what you have to work with in the bid phase. As you can see with these examples, business development and winning work is rarely only about the price or schedule of the proposed work.
Okay, so that brings us to the end of our presentation for today. We've covered a lot of ground, showing that when we break down the work processes that need to be completed, that there are actually quite a number of different workflows. But I'm sure you've been able to identify one or two places where this will be useful to you in your businesses. So if you have any questions about what we've shown you, or you would like to have more information about this, please just drop a comment in the chat box and I would answer. Thank you very much.
Thank you, Dolapo. As he said, if you have any questions, please send them on the Q&A and then he'll be able to answer them for you. Thank you all. I see that we don't have any questions for Dolapo. Well, we have come to the end of the webinar. So what I'll be doing is I'll be sending the webinar recording to all of you. So if you have more questions or anything that you would like to ask us, please do send us an email and we'll be able to respond back to your email. Thank you and have a wonderful day to all of you.
Thank you, Rantula. If anyone would like to be contacted by the resellers? I think it will be good to indicate.
Yes, thank you, Dalapo.
Okay.